Algebra 1, this is chapter 6.2. Today we're going to do the substitution method for solving systems of equations. These always will find a solution, if there one exists. So, I got 5 steps for solving by substitution, and it all comes down to substitution being plain coach. I am going to put something in for something else. And so the steps are, number 1, solve one equation for a variable. Step 2, once I have a variable solved for, it will be something like y equals some x's, or x equals some y's. You're going to take that expression from that first step, and you will substitute it into the variable that you had solved for in the other equation. And it's always the other equation. You can't put it back into the same one. That doesn't work. Once you have put it into the other equation, you're going to find that you have one equation left, but that one equation is made up of a single variable, which means you can solve for it. And so that means in step 3, you solve for the remaining variable. So now you have x equals 2, or a y equals 3, or something on those lines. Once you have that, you can use the variable you have now found, using the found variable, substitute again back into the solved expression, the one you solve for the unknown first, to solve for the remaining variable. And then the last thing you should always do is check your answer. Now here's the problem. It sounds like it's very scary because this seems to be solve for a variable, use the known variable to solve for unknown variable, and plug it back into another variable, right? It just seems variable, variable, variable. But it really what it comes down to is getting the equation down to one and to one variable, and then once you have a value for a variable, you're able to solve for the other. Okay? So what we have here is I think I have like 4 examples total today. 2 of them we're going to solve that'll give us answers. 1 of them there's no answer, and the other one there's going to be infinite many solutions. The same 3 options that we had when graphing, we are now going to be able to solve algebraically. So the example we are going to try to solve first by substitution is y equals 4x minus 6 and 5x plus 3y equals negative 1. Now if I was going to use substitution, again, step number 1 says solve one of the equations for a variable. Well, guess what? I'm like you guys, I'm lazy at times. And I want to do the least amount of work, which means I'm going to try to find the variable that I can solve for the easiest. And if it's already done, I'm using that one. So in this case, y equals 4x minus 6. It's already done. But the thing is, I don't have to use that one if I don't want to. I could, in the first equation, solve for x, which means add 6 to both sides and then divide by 4. But that would create some fractions. It's going to create more work. I don't want to do that. But I could solve for this x down in the second equation by subtracting 3y from both sides and then divide by 5. Or solve for this y by subtracting 5x and then divided by 3. It will work. You could solve for any of those variables and plug it into the other. It works. So, Since we already talked about the fact that this has already been solved, that's why. If you guys came up to me today and said, hey, the soda machine's not taking my dollar, what would you probably ask me for?
$1.
In
$1.
quarters. Would you guys be okay with exchanging 4 quarters for that dollar?
Yep.
Yeah. This is what we're going to do, guys. Think about what's going on. What's going on is that you have one equation here, another equation there, and you're looking for x comma y where they intersect. Yes? And this means that they share the same x and they share the same y. So guess what? This y is the same as that y. But this y is equal to 4x minus 6. So I am going to take that 4x minus 6 and I am going to place it into the other y. Now watch how I do this, because I want you guys to get this right. The 5x I am not changing. Plus 3 times something is equal to negative 1. What we have here is I am taking the value of y and I'm taking it out. And when I take that y out, it's left with a hole here. And what I'm going to replace into that hole is 4x minus 6. Now that we have substituted 4x minus 6 in for y, I have a single equation, one equation, with only one type of variable, and the one type of variable is x. And so now, can you solve for x? Yeah. I hope everybody sees that 5x I'm not doing anything with, but I'll take the 3 and 3 times 4x is, and 3 times negative 6, negative 18 is equal to negative 1. I'm going to gather up like terms. 5 plus 12x. So 17x minus 18 is equal to negative 1. And then I'm going to add 18. And I will end up with 17x equals, I meant 18, so 17. And divide both sides by, so x equals 1. Are we done now? No, because to be done, we need to find x and y. So, options, guys. How do I solve for y? Do I do the same exact thing, but this time maybe solve for y and put it in for x? Or solve for x this time and then put it in? No. There's an easier way.
You plug the x into the y equals equation?
Yes. Go back to your original problems. You already have x's and y's here. If I put in 1 in for x, it'll get rid of it, and I'll be able to solve for y. And either one of them, really. But guess what? Y equals seems to be a pretty good choice to solve for y. So, y equals 4 times 1 minus 6. Or 4 minus 6, which is negative 2. So y is negative 2. Are we done now?
We gotta check it.
Well, we got to check it, but actually we're still not done. What are we actually finding here? We're finding this. What is this again? Point of intersection. So you should probably write it as a point. And what would this point be? 1, negative 2. Now, in step 5, like all good students, we check our work. You plug it where? Into the original problems. Equations. Can I just check it in one of them?
Yeah, because if one doesn't work.
No, you got to check both. But if one doesn't work, then you don't have to go any further. So, here we go. Y equals 4 times 1 minus 6. Oh, sorry, that's not y equals, it's negative 2 equals, right? Or negative 2 equals 4 minus 6, which is negative 2. Check. Left-hand side equals right-hand side. We're good to go. Next one, it's going to probably take a little bit more work. 5 times 1 plus 3 times negative 2 is equal to negative 1. Is that true? 5 minus 6 equals negative 1. Or, I'm going to put it way on the bottom, negative 1 equals negative 1. Is that true? Check. So therefore, we are right. Guys, substitution method works every single time, as long as you do the math correctly. So just do the math correctly, you're fine. This is the next problem. I want you guys to solve this one on your own. We'll come together to solve it. 4x plus 5y equals 11, and y minus 3x equals negative 13. Solve this by substitution. So, looking at these equations, which variable looks to be the easiest one to solve for, and why? Hayden?
The bottom one.
4?
Y.
The bottom, y, because?
You just have to add wait. No, you have to add 3x to...
So if I just add 3x to both sides, I will have y by itself. Guys, what I'm looking for when I do this is that this won't always happen. They're not always going to have a variable just kind of by itself. But if they do, I'm really happy. And so I'm always going through a checklist. My first checklist is, hey, do any of these have a coefficient of 1 or even negative 1? Because if it was negative 1, I just bring it to the other side and it gets positive 1, right? So that would be really easy. But then I also start looking for the fact that, hey, if I wanted to solve for this x, I would have to divide everything by 4. Is 5 and 11 divisible by 4? Nicely. No. Could it be done? Yes, but I would have fractions, and that's not so fun. I go to 5. Can I get rid of 5 by dividing everything by 5? Again, 4 and 11 don't divide by 5 very nicely. What about this x? Divide everything by negative 3. No, 1 and negative 13 don't divide by negative 3 very well. So, if I wanted to solve for those others, I would have to introduce fractions, and again, I would rather not. So, I will definitely solve for this y, and I do that by adding 3x to both sides. So I get y equals negative 13 plus 3x, or 3x minus 13. It does not matter, correct? And again, I will place this into that top equation for y. So 4x plus 5 times something equals 11. And what is that something? Negative 13 plus 3x, or 3x minus 13. It doesn't matter. Don't forget to do what with the 5? Distribute. What's 5 times? What's 5 times negative 13? Negative 65. 5 times 3? And that should equal 11. 4x plus 15x happens to make minus 65 equals 11. Add 65. 19 equals 76. 1976. Bicentennial, guys. Divide by 19. X equals? 4? 4. And then, of course, where am I placing this?
That's for x.
Yeah, I'm going to take the x and place it. Could I place it here? Yes, it'll work. Could I place it here? Will that work?
Sure.
Yes. Guess what? There's a better option. I like option 3. What's option 3?
I don't even know. Don't do it. Leave it like that. Leave it like that.
No, option 3 is put it into this equation. This equation, guys, is the second equation right here, right? just already modified to say y equals. Why wouldn't I place it into the equation that is solving for the variable I want? That makes sense. So y equals negative 13 plus 3 times 4, which is negative 13 plus 12, which is negative 1. And so it's 4 comma negative 1. Guys, I would check this to save time for us. I am not going to check it, but it should work out fine.
I checked it and it worked out.
Now we have to talk about those other two cases. We talked about case 1 where there's one solution. Now we got to talk about infinite many solutions and no solutions. Guys, example 3 will have no solution. I'm already telling you this. This is where you guys are going to figure out on your own. Guys, stop talking. What I want you guys to do is solve this system knowing there's no solution. I'm going to give you some time. I want you to tell me why or how you would know by doing the work that there is no solution to this problem. Ladies and gentlemen, without actually doing any work on the screen, can someone tell me what just happened and how you could tell if there's no solution? Izzy?
The x turned out to be 0.
X turned out to be 0. What do you mean?
Wait, no, just kidding.
Yeah, it does.
Okay.
Yeah, it does.
X becomes 0?
2x minus 2x.
No, what? There is no x.
There is no X when trying to solve for it. Something happened, didn't it? What happened to your variables? They canceled. What do you guys end up being left with? 0 equals 5. When does 0 ever equal 5?
Never.
Never. So therefore, there's no solution. If you guys get to the point where it's two numbers that are supposed to be equal that are not equal, there's no solution. So, hence, placing that into y, right? 2x minus 2x minus 3 equals 8, yes?
Yeah.
Distribute the negative. Minus 2x plus 3 equals 8. Those cancel. When does 3 equal 8? Never. That means no solution. Done. Guys, when does it happen that there's no solution for two lines? When they are parallel. Next question. Do the same process. Tell me why there's infinite many solutions to this.
Oh, yeah.
So, without graphing or without doing stuff, we know if I had to graph these, you would not see the difference. The lines would be stacked on top of each other. What are we guys recognizing on this? It's the same equation. So if you start to substitute one inside the other, everything goes away, right? But they're not different numbers, they're the same number. When does 2 equal 2?
Always.
When does 0 equal 0? When does 10 equal 10? Always. That means there's infinite many solutions. Now, guys, we have to show the math behind this before we leave. The math behind this is the fact that these two equations are just multiples of each other. It's a little hard to see that sometimes, but actually these variables are switched around, so you don't recognize that right now. But we got to use substitution. But oh my goodness, guys. This one does not have one by itself, right? But also, if I want to solve for this x, I got to divide by 4. But is 3 and 1 divisible by 4? Or if I solve for this y, I got to divide by 3. Or if I solve for this y, I have to divide by 6. Or 8. Nothing is perfectly divisible. So no matter what, using substitution, I will end up with fractions. Let's just solve for y in the second equation. Okay, we're going to solve for this y. Which means the first move is to get rid of negative 8x by adding 8x to both sides. Can you guys agree with this? So 6y is equal to negative 2 plus 8x. Is that okay? Next move, get rid of the 6 by dividing by 6. Technically, I just divide everything by 6. What I did was I already had separated it to the both pieces, so I kind of distributed it in already. So, what is negative 2 divided by 6? Negative 1/3. Plus, what's 8 divided by 6? Reduced. 4x over 3. Divide the top and bottom by 2. Can you guys agree with this, guys?
Yeah.
I'm going to take this and put it there. So, 4x minus 3 times negative 1/3 plus 4x over 3 should equal negative 2. What happens when I distribute the negative 3 to the negative 1/3? Becomes plus 1. And what happens to the, it's negative 12 over 3, which is actually negative 4x? What happens to the 4x's? So when does 1 equal negative 2? Never. So this is, wait, there's supposed to be infinite many. Oh, guys, I put the wrong, no one caught it. That's supposed to be what? 1. 1. So now when does 1 equal 1? So, infinite solutions. Homework is page 347, 1 through 7. Have a great day.